Welcome to Foundations of Math 30. This is outcome FM 30.05, lesson 4 on conditional probability of dependent events. So conditional probability is the probability that event A will occur given that B has already occurred. So we could say it's A given B, and the notation we use is A with this slash B. The occurrence of B influences A, so these are considered dependent events. So let's look at an example. I've got 12 Scrabble letters listed there. They're placed in a hat, and one of the letters is then drawn. Event A is going to be considered drawing from the word drums, and we're going to call event B from the word guitars. Now I've created a Venn diagram over here where you can see my event A. Inside of that circle, I've got all my letters for drums. Inside of B, I've got my letters for guitars, and I've got a couple of letters that don't fit in either that are out there. So we know that the probability of event A happening, so drawing a letter in from the word drums, is 5/12, and the probability of event B happening is 7/12. There's 7 letters out of 12. And the probability of A and B happening, so the overlap between the two, is 3/12, which reduces to 1/4. But what is the probability of drawing letters from the word drums given that a letter from the word guitars turned up? So basically what I'm doing here is I'm reducing the number of letters to choose from. So instead of having 12 letters to choose from, I'm telling you that the letters that you have in your hand are from the word guitars, and how many of those form the word drums, right? So what that is saying is now, instead of it being the whole set, my given set is here, and there are 3 of those that belong to the word drum. So the probability of A given B is 3/7. Okay, when we refer to the Venn diagram, it's the number that are in both A and B, so 3, divided by the number that are in B. So we have this conditional probability formula that I'm going to show you, but honestly, we're not going to get too wrapped up in it because we won't need it until the next lesson. But the probability of A given B is the probability of A and B divided by the probability of B. Now, if we just flip that around, the probability of B given A would be A and B over the probability of A. And if we rearranged our formula, like we wanted to solve for the probability of A and B, for example, we can take the conditional probability multiplied. Okay, so these are just some formulas, but again, just for introduction purposes, we'll be using those more in the next lesson. What we can really think of right now is you can think your way through these conditional probabilities and avoid the formula. All that it does is change the denominator of the probability fraction. Okay, so let's go through and look at a few of these and I'll show you what I mean. 2 coins are tossed. What is the probability that both tosses produce tails if it is known that at least one of the tosses was tails? So what we're going to do here is we are actually going to just write out our sample space for this one. So if I'm tossing 2 coins, then what can happen is I can get a head and a head and then a tail and then a head, or a tail and then a tail. So I just only have 4 possible outcomes to choose from. So it's basically saying, what is the probability that both tosses produce tails if it is known that at least one of the tosses was tails? So it's saying, what is the probability of getting 2 tails given that I know that I had 1 tail to begin with? So what that is saying is, instead of having my 4 possible outcomes, I'm telling you that I know that I have at least 1 tail. So that means it's down to only the ones that contain tails. So I have 3 outcomes to choose from, and of those 3s, just this last one produces 2 tails. So it's 1/3. Okay, let's look at this one. It says, suppose you have 4 pennies, 3 nickels, 2 dimes, 2 quarters, 2 loonies, and 1 toonie in your pocket. Okay, so you have, what is that, 7, 10, 12, 14, 15 coins in your pocket. If you reach into your pocket in a hurry for a coin for the parking meter, what is the probability that the first coin you touch will be a nickel if you instantly realize the coin is too small to be a loonie or a toonie? Okay, so what we're doing is we're busting down our total. We don't have 15 to pick from because I'm telling you that it's too small to be a loonie or a toonie. So the notation there is, what is the probability that it's going to be a nickel given that it's not a loony, not a loony or a toonie. Okay, so basically I had 15, but I'm telling you it's not a loony or a toonie, so these are gone. So now I only have 12 outcomes left because 3 of them are gone from my sample space out of the 15. And how many of those are nickels? Well, 3 of them are, so 3 12ths, which reduces to 1/4. Okay, let's look at the next example. We're going to be reading a chart. So it says, after a 50-game season, a basketball team summarized the number of wins, losses, and ties for at-home and away games below. So we're just going to get started reading this. It says, what is the probability of getting a win? So if we look at this chart, what we know is that these are my wins at home, away, my total wins, my total losses, my total ties. These are my at-home games, my away games, my total games. So I have a total of 50 games. No conditions, just how many wins did I get? So the probability of getting a win is out of my 50 games, I won 29 times, so 29 out of 50. The probability of getting a loss, so out of my 50 games, how many losses did I have? 17. And how many ties? Out of my 50, I had 4. That reduces now to 2 out of 25. Okay, now let's look at some conditional probabilities. So it says the probability of getting a win given that I was at home. So what that now is saying is don't look at my total column over here, just look at the at home column. So when I'm at home, I played a total of 22 games. And of those 22, how many were wins? Well, 18 of them were, right? So if I reduce that, it comes down to 9/11ths. Now, what is the probability of my getting a win given that I'm away? So again, don't look at the total, we're looking at the away column this time. So I have a total of 28 games played away, and 11 of those are wins. The probability of losing given that I played away. So again, I'm looking at my away column. I have 28, and how many of them are losses? 14 of them, so that reduces to 1/2. Okay, question number 4 says, 2 cards are drawn at random from a deck of cards without replacement. So you draw one, you keep it, then you draw another. What is the probability that both cards are red? So I just wanted to do a question like this because we never looked at one of these in the last section because we were looking at only independent events there, but this is a dependent and question. I want to get a red and then a red, but the difference here is that I'm going to keep the first card and then draw another. Okay, so when I do my first card, out of my 52 cards, there are 26 reds. Agreed. But now the difference is you're holding a red card in your hand. Assume that you drew a red the first time, otherwise why would you keep going? So now there are no longer 52 cards in the deck, there's 51, and there's no longer 26 reds, there's 25. Okay, so this is an example of an and statement where I have dependent events. When I plunk that into my calculator, this comes out to be 25/102. Again, remember, if you don't have a fraction key on your calculator, you can always work in decimals. This guy comes out to be 0.245. Okay, so you can go ahead and practice with some conditional probabilities now.